The next decimal to any radix we will continue the topic successive multiplication for fractional part conversion. Okay, so up to now we did the examples only integral part only, right? So now if that integer part also contains fractional part in decimal number, that fractional part will be converted to any radix. How you will convert? That is a successive multiplication for fractional part conversion. So here there are totally 4 steps are there. So for those steps you will follow, you will get the result that is decimal to any radix. The first one is multiply the fractional part of decimal number by desired base number. By the desired base number. For example, convert the decimal number to binary. That is 12.125 base 10 to base 2. So this is the example, that is decimal to binary value. So you know that without fractional part, you will be convert from 12 to base 2. How you will convert means you have to divide it by 2. This number you have to divide it by 2. Then you can write the result from bottom to top. So here there is a fractional part, right? There is a fractional part. So first you will be convert this fractional part to any radix, that is decimal number to any radix means multiply this fractional part of decimal number. So this is the decimal number, right? So multiply the fractional part of decimal number by desired base number. So what is the base number here? 2.
2.
So you have to multiply by this number with 2. And the second step is record the integer part of product as carry and fractional part. So second one is read the integer part of product as carry and fractional part as new fractional part. So these first and second steps are repeated until fractional part of product becomes 0. So these are the 4 steps to convert the decimal to any radix in successive multiplication for fractional part conversion. So first step, what I told you now. So first 0.125 into 2. So this is the first step, that is multiply this fractional part of decimal number by desired base number. That is the base number is 2. Then 0.125 into 2. What is the value 0.125 into 2?
0.250.
0.250. Okay, 250. So in this 0.25, the second step, what I told you, record the integer part. So this is the integer part, this is the fractional part. Record the integer part of product as carry. That means 0 will become as the carry. And again there is a new fractional part is there. That fractional part is again you multiplied by 2. That is 0.25. That is 0.25 into 2. Then what is the 0.25 into 2?
0.5.
0.5.
Yeah, 0.5. Again here the carry is 0. Again 0.5 into 2. What is the value now?
1.
1.0, right?
Yes, ma'am.
Yes, 1.0.
So here Here the integer part can contain the value is 1. So here the fractional part is 0. Then we will stop the multiplication here. That is the third step what I told you. Repeat the steps 1 and 2 until the fractional part becomes 0. ఒకవేళ 0 రాలేదు అంటే until you have many digits as necessary for your application. How many digits you want, that much of multiplication you did. That means, for example, 0.25. Again, this number is come in next multiplication sequence. There you can stop. Ala kuda raledu. Then you can take 6, 7 multiplication values, then stop and write the result. Is it clear? Here the output, how you can write the output here? From top to bottom. From top to bottom. So first, this is the 0.125. Here 12 is there now. So for 12 decimal number, decimal to any radix means what is the process here? You have to divide it by that radix, right?
Divide.
2 is the 12.
6.
The value is 0. 2 3s are 6.
Right.
The remainder is 0. 2 1s are 2. Remainder is 1. And how you will
Reminder
write
is
the
1,
result now?
1, 0.
The bottom.
1 1 0 0. So now
Bottom
here
to
result is, yeah, 12 is 1 1 0 0. Point 0.125. What is the
1,
result?
0, 0.
0 0 1.
Here we can take the values from top to bottom. That means,
0 0 1.
yeah. So this is the value. Is it clear, ma? Application for fractional part conversion. So first, what you did in this means first step is multiply this fractional part of decimal number by desired radix number, that is base 2. Next, record the integer part of product as carry. And again here you will get a new fractional part. That will be again fractional part and multiplied by that radix. And the next third step is the first and second steps are repeated until fractional part becomes 0 or until you have many digits as necessary of your application. That means if the fractional part does not contain 0, some more than you can get 10 values. Not you will get the desired value 0 fractional part. Then so these fractional part are repeated anywhere in next steps. Then you can stop there. Then you can stop there and write the result. The fourth step is from bottom to top. So it carries whatever the carries are there. That carries you can take from top to bottom. So by this way we can calculate the fractional part, integer part as well as fractional part. Is it clear now? 658.825. So 658.825. Convert this decimal to binary and tell me the result.
1 0 0 1 0 0 1 0.
1 0
1 0 0 1 0 0 1 0.
Mali
1
1 0
0 0 1 0.
Yeah, very
Yes,
good.
ma'am.
Next point. What is this value? 0.825. Then I will explain this. 0.825 into 2. What is the value now?
No, ma'am. 3.30.
1.30 something was 0.65 into 2.
Yes, ma'am. 1.30, ma'am. Yes,
So here the value is 1. You can write the value 1 here. And again you will be multiplied by 0.30 into 2. Then what is the value?
0.6.
0.6, that is okay. So next, again 0.6 into 2,
1.2.
1.2.
1.2. So here 1.
1.
Again here
0.2.
0.2 into 2,
0.4.
0.4.
0.4. 0.4. Again 0.4 into 2,
0.8.
0.8.
0.8.
Again 0.8 into 2,
1.6.
1.6. So clearly here you can observe. So at the fractional part there is no 0, right?
Yes.
So మీరు multiplication చేస్తుంటే the values are going, but at the fractional part we are not getting 0, right? So
Yes, ma'am.
where we can stop this value means we can take some 6, 7 values and stop it. Otherwise one more option is there. So here these values are repeated anywhere in next process. Yes, here we are repeating, right? 0.6 into 2. Here also the next step is 0.6 into 2, right?
Yes, ma'am.
So then we are going to stop here and write the result from top to bottom. So now 1, 1,
1,
0,
0,
1,
1,
0,
0, 0.
Is it clear?
Yes, ma'am.
So
Yes,
at the
ma'am.
fractional part, we didn't get value 0. Then we can take 7, 8 multiplication values. In that, again, we will cross check there. 1 or 2 steps to mali repeated values. There we can stop it. No need to consider as 0. So at the third value, again, I get 0.65 means there we can stop. Is it clear?
Yes, ma'am.
So like this, we can convert the successive multiplication for fraction. Okay, next example, convert this same value 658.825 decimal into octal. Decimal into octal. Okay, 658.825. This is the decimal value. This decimal value will be converted to octal. Then what is the procedure now? What is the procedure?
Divide by 8.
8, ma'am.
Yeah, so 658 is divided by 8 and this fractional part is multiplied by 8.
8.
Yeah, so here 658, it is divided by 8 only first. So what is the value? 8 8 is 64.
Remainder 1.
Remainder 1 and 8 2s are 16. Remainder is 2.
2.
Yeah. Next 8 10s are 18. Remainder is 2.
2.
Reminder is
Next
2.
8 1s are 8. Remainder is
Remainder
Okay.
is 2.
so you can write the result from bottom to top.
Bottom to top.
Next 0.825. 0.825 into 8. What is the value now?
6.6, ma'am.
6.6. Now what is the here
6.
integer
Ma'am.
part? 6.
6, ma'am.
6. Next again 0.6 into 8.
4.8, 4.8, ma'am.
Endamma?
4.8, ma'am.
8, ma'am.
4.8, ma'am.
4.8. Again here the fractional, sorry, integer part is
4.
4 and fractional part is 0.8 into 8.
8 into 8. 6.4, ma'am.
6.4, ma'am.
So 6. Again 0.2 into 8. 1.6.
1.6, ma'am.
So here again, so 0.6. So that value is repeated now.
Yes, ma'am.
Yes,
ma'am.
So we
ma'am.
will stop here. The procedure we will stop here. Okay, so at 5 steps we didn't get fractional part as 0. So again, this value is repeated now, 0.6 into 8. So at this step, we will stop the procedure.
Triple two.
658 is nothing but 1,222.
0.64631.
631.
64631. Okay. So by this way, you can get a decimal to octal. Next, one more problem you will do and tell me the result. 5386.345 base 10 to base 16. What is the result for that? Anyone?
150A, ma'am, for 5386.
150A.
0A.
150A. Correct. Next, 0.345 into 16, right? So then what is the value now?
5.52.
5. Again, 0.52 into 16. So here the value is 8.32. And again, 0.32 into 16. The value is
5.12.
5.12, ma'am.
okay. So again, you will calculate 0.12 into 16.
1.92, ma'am.
1.92.
92, ma'am.
Okay. And again 0.92 into 16.
14.72, ma'am.
14.72. Here 14 means E. E. Okay, Nandi. Is it clear?
Yes, ma'am.
Okay, ఇక్కడ 14 రాయకూడదు. So that's why here I am writing E. So in decimal to any radix, if the decimal value can contain both the integer part as well as fractional part, so that integer part is divided by the radix, that fractional part is multiplied by the radix. Decimal numbers. First one, 250.5. Second one, 12.0625. And third one, 673.23. Convert the decimal numbers: 250.5, 12.0625, 673.23 to binary, octal, hexadecimal, comma, base 3, comma, base 4, comma, base 7, comma, base 7. So దీంట్లో మీకు తెలిసింది convert decimal numbers to octal and binary and hexadecimal, right?
Yes, ma'am.
So here base 3,
Yes, ma'am.
base 4, base 7, same like that only. So convert the decimal number base 3 means you have to divide it by 3. This number and this number is multiplied by 3. Is it clear? And this number base 4 means you have to divide it by this number by 4 and multiply it by 4. Is it clear now?
Yes, ma'am.
Yes, ma'am.
Okay, so this any doubt?
No, ma'am.
Oh, ma'am.
Okay, so conversion we completed, that is decimal to any radix. Decimal to any radix is completed. Next one, convert any radix to decimal. 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 So in this, we will be convert binary to decimal, hexadecimal to decimal, or octal to decimal, or any radix to decimal. That means in the base 3 చెప్పాం కదా, base 3 to also will be converted to decimal. Base 7 is also converted to decimal. So that means any radix to decimal, here we will convert binary to decimal, hexadecimal to decimal, octal to decimal. And any base, that is base 4, base 7, base 5, those also will be converted from that radix to decimal. So here, what is the procedure? Okay, so what is the radix to
Powers,
decimal?
ma'am.
Ma?
By adding powers, ma'am.
Yeah, by adding the powers. So that way we convert that radix to decimal.
Decimal.
So for example, first we will discuss binary to decimal. For example, 1010. This is the base 2. We will convert it to decimal. So what is the radix now? Here 2.
2.
So this will be 2 power 0, 2 power
2
1,
power 1, 2
power
square,
2 power
2 cube,
So 1 into 2
2
power
power
3
3,
plus 0 into 2 power 2 plus 1 into 2 power 1 plus 0 into 2 power 0. You will start
10, ma'am.
from left, right to left. Okay. So 2 power 0, 2 power 1, 2 power 2, 2 power 3. So 2 power 3 is nothing but 8. 8 into
Plus
1, 8. So 0 into 2 power 4,
0.
that is 0.
0 plus 2, 0.
0. What is the value now?
10.
So 10 is the answer. Is it clear how to convert binary to decimal? Means you will be multiplied with the power series. So we will multiply each and every digit with this radix and add those terms, and we will get the equivalent decimal value. Is it clear, ma? How
Yes,
you
ma'am.
will
Yes,
convert? Okay. Up to now, you have any doubts regarding these concepts?
No, ma'am. No, ma'am.
Everyone has clear?
Yes, ma'am.
Yes, ma'am.
In next class, we will continue these concepts, and in next class also we will discuss complements also. 1's complement, 2's complement, 10's complement, 9's complements. So all these things we are discussed in next class. So up to now, no doubts, na?
No, ma'am.
Okay, ma. Thank you.